Okay, so here is example 2 on lesson 3.4, solving problems involving linear equations. Okay, so, all right, let's take a look at the question and underline what's important. All right, there were a total of 750 people at the last performance of the High School Musical. Adults had to pay $8 each, and children under 13 had to pay $3 each. The musical took in a total of $4,815 in ticket sales. How many adults and how many children were there? This looks an awful lot like our other problem from the last lesson about the cars and the buses. The only difference here is that I want to solve this with only one variable, not with two variables. Okay, so in the cars and buses question, we had a C for the number of cars and B for the number of buses. But that's not how we want to do this one. Remember, for all of these equations, we only want one variable because we want to be able to solve for that one variable. So, let's take a look. Remember, step 1, kind of figure out how this works. So basically, we can do it like this. We can say, all right, 8 times the number of adults. This is how much money we're going to bring in. Plus 3 times the number of children will equal the total amount of money, which is $4,815. So this is an amount of money brought in by adults. This is an amount of money brought in by children. And if you add money to money, you get money. So you have to make sure when you're making up an equation, you have to make sure that your variables all match. Money plus money equals money. Distance plus distance equals distance. You can't do distance plus time, and then what do you get when you add distance to time? I don't know. So things that you add together or things that you subtract have to be in the same units. Okay, so how many adults and how many children were there? Generally, the last sentence in a problem will tell you what your unknowns are that you have to find. So you pick one of the things that you have to find and you let it be a variable. So in this case, I'm going to say let A represent or be the number of adults. Okay, so now there's some information in this problem that'll tell us how many children. There were a total of 750 people at this performance. So let's say 50 of them were adults. Well, that would mean that 750 minus 50 would be the number of children. Or let's say there were 200 adults. Well, then that means that 50 minus 200 would be the number of children. So it looks like we're taking the 750 and subtracting how many adults there were at the performance to get the number of children. So that means that if we take 750 and subtract the number of adults, which in this case is A, that's what's going to represent the number of children. Okay, so remember, step 1 is introduce a variable to represent one of your unknowns. Step 2, whatever other unknowns you have, you want to express them in terms of that variable using some other information in the equation. Step 3 is make an actual equation. So from up here, we want 8 times the number of adults, so that's 8a, plus 3 times the number of children, but the number of children is 750 minus a, and that would have to equal 4,815. And now, step 4, we solve this equation. So that'll give us 8a plus 3 times 750. What's 3 times 750? I've forgotten. Okay, so 2250 minus, so that's got to be multiplied by that, and by that. Remember, you need brackets around this piece here. And then that's minus 3a equals 4815. All right, our a's are going to stay on the left, so that's 8a minus 3a, but the 2250 needs to go over to the other side. 8a minus 3a is 5a, and 4815 minus 2250 is 2565. Divide both sides by 5, and we get that a is 513. So 750 minus 513 is 237. So therefore, there were 513 adults and 237 children. Okay, I'm going to do the next example in another video.